Section 1.5, linear equations, functions, zeros, although we have talked about zeros of functions a little bit. I've got one example at the end of the section. And applications of linear equations, linear functions. Example 1, jump right into the applications. Kind of the understanding is that in the algebra course prior to this one, and probably in the algebra course prior to that one that you've solved linear equations. So I'll try to take each one step by step with the idea that we simplify both sides of the equation. We try to isolate the term that has the variable in it, but the emphasis here will be on the applications rather than just the plain vanilla solve for x type of linear equations. So we've got an equation involving simple interest. Joan recently inherited $60,000. Sad for her loss, happy for her gain. Wants to invest it so as to achieve a total annual return of $3,000. Not sure where she got her mindset on this $3,000 number, but evidently she doesn't have anything that she wants to spend the money on right away, but she feels like if she can just kind of wait a year, and then a year from now try to figure out how she can spend $63,000, maybe she'll have it figured out by that point. But she wants to earn $3,000 in interest from this investment in the next year. She's got some options. One option is a certificate of deposit, a CD. Now the rate on this particular CD is considerably higher than what we would get if we just went to a financial institution this particular year. 4%. Doesn't seem like it's going to make her rich, but it's a little bit more generous than financial institutions are able to be at the current moment. 4% though of $60,000 is how much? Anybody? What is 4% of $2,400? So if she puts all $60,000 in the certificate of deposit, that'll earn $2,400 interest, but it won't be the $3,000 that she wants. Now she's not up for a whole lot of risk, but there is, well, let's see. Her cousin Bernie suggests that she invest some of the $60,000 in a fund that he has that he insists will yield an annual return of at least 20%. She'd certainly be content with 20% of whatever she might invest in that, but she's a little bit concerned that there might be more risk involved than she's willing to tolerate. She's going to invest a portion of it in that fund that Bernie has suggested to her, but she wants to invest as much as possible in the CD, keep it safe. So the question is, how much of the $60,000 should she consider placing in the CD? How much should she consider placing in the in Bernie's fund so that the total interest earned from the two investments will be $3,000? Now I want to take a one variable approach to this. If you've recently taken intermediate algebra with us, we do a section called Applications of Systems of Linear Equations, and we do a problem like this with a couple of variables, an x and a y. But I want to take a one variable approach with it. Let x be, there are a couple of things that we don't know. We don't know how much she should invest in the CD. We also don't know how much she should invest in Bernie's investment fund. Let's let x be one of those. Anyone have a preference? Let x equal the amount to be invested where? In the CD. In the CD. Now if we were taking a two variable approach, what we would do is say let y be the amount to be invested in Bernie's investment fund. But it's just a one variable approach, so we have to think about this. Suppose that she goes with $50,000. She buys a CD, $50,000, and puts the rest of it in Bernie's fund. How much then would go into Bernie's fund? Total of $60,000. Putting $50,000 in the CD. How much? 10. The question would be, how did you get $10,000? Yeah, you take the $60,000 and you subtract the $50,000, and you get $10,000 without even realizing it, probably. So I'll say then, if we take that $60,000 total and subtract X, the amount that's going to be invested in the CD, this is going to equal the amount invested in Bernie's fund. There we go. So X in one place, $60,000 minus X in the other, for a total of $60,000. Now we want the total amount of interest from one, from the other, add those up, get $3,000. So I'm going to say the interest earned from and just to remind myself what the annual interest rate the CD is paying, from the 4% CD plus the interest, well, you wouldn't technically call it interest, but it's the net yield, I'll call it interest nonetheless though, earned from the 20% Bernie's fund She wants a total of $3,000. If it works out to be more than $3,000, she'll be fine. We could think of this as an inequality, but I want to think of it as an equation. Imagine that she can get exactly $20,000 out of Bernie's fund. The total then would be $3,000. This should be enough to get an equation, provided we know the simple interest formula. Anybody happen to know the simple interest formula? That's the one. I equals P times R times T. Interest equals principal times rate times time. Here, the time is 1 year. She's just going to go 1 year. Hopefully she's going to have $63,000. And she'll be able to make a new decision a year from now as to what to do with that $63,000. So that's going to be one. The principals are both unknown, but we've got those expressed in terms of X. The interest rate, for one, we know is 4%. We'll convert that to a decimal, 0.04. The other one's 20%. We can call that 0.20 or just 0.2 if you like. And the interest is what we'll calculate in each of these great big sets of parentheses. So this interest would be principal times rate times 1, I'll say. Principal X dollars going into the CD times the rate, 0.04, times the time of 1 year. Interest earned by Bernie's fund, if it pays 20%, that's going to be $60,000 minus X times the 20%, which we can write as a decimal, 0.20. And that's going to equal $3,000. Can we solve this equation? Can we do this? Let's go ahead and hang on to the decimal places. Typically decimals are a lot easier to deal with than fractions. If we wanted to multiply both sides by 100, we could eliminate the decimals, but the numbers get really, really large. So I think just deal with the decimals the best way we can. So simplifying, we get 0.04x plus, if we distribute the 0.20 across the parentheses, we said 20% of $60,000. I don't know it. We did not calculate 20% of $60,000. What is 20% of $60,000? How much? $12,000. $12,000 minus 0.20 times X. If Bernie's fund were FDIC insured, maybe Joan would take the risk and invest all of it in Bernie's fund and maybe get $12,000 interest out of the deal rather than the $3 that she seems to be contenting herself with. But there's so much risk involved there, she doesn't want to take that plunge. Let's combine like terms. We've got a 0.04x on the left-hand side and a negative 0.20x on the left-hand side. If we combine those x terms, what would we get? How many x?
Negative 0.16.
Does everyone feel okay about that? Negative 0.16x. Line up the decimals. Negative 0.20, positive 0.04. The negative 0.20 is greater. So when we add these, it's going to take that sign. It's going to be negative. And the difference is 0.16. So negative 0.16x plus $12,000 equals $3,000. Okay, we got to just, there's one x term. It's on the left. It's not all by itself on the left. Ideally, and certainly, we have to have that x term all by itself on the left. So let's subtract $12,000 from both sides. And I'm hanging on to the dollar sign here. Final answer x is going to be a dollar amount. Number of dollars, the amount of dollars, the amount of money that she's going to invest in the CD. So we want to make sure we hang on to those dollars. If we had dollars in every term, we could divide both sides by a dollar in a case where x is maybe the number of pounds of a substance or something like that rather than dollars, and we could do away with it. But we need to hang on to the dollar sign. Negative 0.16x, I'm going to cancel those 12,000s there. This equals negative $9,000. Just about there. What do we do next? Let's divide both sides by negative 0.16. Negative 0.16 is the coefficient. We call it the coefficient of x. We divide both sides by that, and that will give us 1x on the left. And on the right, a negative divided by negative is going to be some positive dollar amount here. How much?
56,250.
I think Joan is going to feel pretty good about this. Because of the $60,000, just about all of it is going to go in that CD. FDIC insured. She's going to sleep well knowing worst case scenario, she only stands maybe to lose some, maybe all, who knows, of how much is going to go in Bernie's fund?
750.
$3,750. So to answer this, we would want to indicate how much of each, and we've got some numbers here, but X wasn't given in the problem. I just want to make it clear this is the amount to be invested in the CD. This is the amount to be invested in Bernie's investment fund. I'd like to check the answer whenever possible if it's a problem that involves words, not just an equation. We want to go back to the original words, the original statement of the problem, and make sure these particular answers that we've gotten make sense. Let's calculate the amount of interest that she would earn if she invests $56,250 in a CD that pays 4%. So for a check here, what is 0.04 times $56,250? How much interest? $22.50? So $2,250. If Bernie's fund not only returns her principal, but also pays 20% interest on top of that, the interest that it's going to pay is 20% of $3,750, which is, there we go, $750. For a total of Here we go. There's a $3,000 that she's hoping for. No doubt she'll have to pay taxes on this money. I imagine she will. But 3,000 is what she had her eye on, and this is how she would need to distribute the money between the CD and Bernie's fund in order to make this happen. If she puts more at risk by investing more in Bernie's fund because it's paying the higher interest rate, maybe, fingers crossed, then she can make this number go higher. But if she invests it all in the CD, it's just going to be the 4% of $60,000, which was just the $2,400. Feel good about this one? Any questions? Seem okay? All right. Let's look at the next one. It is not that one. Let's draw the picture for this one. The length of a rectangle is 3 meters greater than twice its width. 3 meters greater than twice the width of the rectangle. Find the width and length if the perimeter is 33 meters. Okay. It would be, I think, an unusual situation actually to be given this collection of data about a rectangle in real life, let's say, and not know the length and not know the width. But it's a question that we're able to answer. So let's see if we can approach this. Let's draw the rectangle. Typically, we think of the width as the shorter dimension, the length as the longer one. And let's label them. You like the variable x for the width, or you want to use w for the width? Anybody have a preference? W for width. Everyone good with w? All right. I'm going to say this is the width. And the length then, if we're taking the one variable approach to this, the length ought to be expressible in terms of the width. The length is 3 meters greater than twice the width. Twice the width would be 2w. A quantity that's 3 units greater than that would be what? 2w plus 3. So let's go with 2w plus 3 for the length. Now, the perimeter of a rectangle is the sum of all 4 of its side lengths. So one approach we could take is to say w plus 2w plus 3 plus another w plus another 2w plus 3. Add all those up, set that equal to 33. Solve for w. Typically, though, we might use a formula for the perimeter. If you've got the length and the width, what's the formula for the perimeter of a rectangle? Length times width would give us the area, yes. And we'll do that problem before we're done with the semester, just not today. Well, you've got the width, and then you've got the width again. Those have to be added up. 2 of those. You've got the length, and then the length again. Those have to be added up, so 2 of those. So if we do it in alphabetical order, 2 times the length plus 2 times the width. That'd be one way to express the formula for the perimeter of a rectangle. So I'm just going to substitute what we know. We are told that the perimeter is 33 meters. And I think I want to leave off the meters. Hopefully we won't get in too much trouble. As long as we understand that the final answer should be expressed in meters. We want to know the width and the length. We'll express the width in meters. We'll also express the length in meters. So 33 equals 2 times. We have an expression for the length in terms of w, 2w plus 3. And then we have 2w. We'll solve it for w, get a number. This will represent the width in meters. We should then be able to calculate the length in meters. Simplify the right-hand side. 33 equals distribute the 2 across the parentheses. 4W plus 6 plus 2W combine like terms. We've got a couple of W terms on the right hand side. We combine the 4W and the 2W. We will get 6W, and then we still have the plus 6. This equals 33. Down to one W term now. We can isolate that W term if we subtract the 6 from both sides. 27 equals 6W. Essentially one more step. What are we going to do? Divide both sides by 6, the coefficient of the W. I'm going to interchange the two sides as I'm doing that. I'm going to say 6W divided by 6 equals 27 divided by 6. So basically interchanging the two sides, which we can do to an equation, that gives us an equivalent equation. Divide both sides by 6, and W is going to be 4.5. Think my math lab would be okay with 4.5?
Depending on which one it was.
Maybe. 4.5, 9 halves is what this reduces to. So if it doesn't like 4.5, go with 9 halves. 4.5 is probably going to be a little bit easier for us, though, to calculate the length. The length is going to be 2 times something plus 3.
2 times 4.5.
There we go. So 2 times 4.5 plus 3, 9 plus 3 equals 12. So the width, we want to check this, but the width of the rectangle is 4.5 meters. The length of the rectangle is 12 meters. And if we use those dimensions, well, we need two things. We need 12 to be 3 more than twice 4.5. Feel pretty sure about that. But we also need the perimeter of this rectangle to be 33 meters. If we take twice 12 and twice 4.5 and add those together, will that give us 33 meters? There we go. So if 12 is 3 more than twice twice 4.5, it certainly has the correct perimeter, so these are the dimensions that we want for this rectangle. Is that a hard problem or an easy problem? No? A little easier, I think, than the area problem that will come later, but still something to think about. Thinking about the formula of the perimeter, or how we could express the length in terms of the width. Things to think about. Sample 3. I can zoom in on that just a little bit. If all we had to do is calculate sales tax, I don't think that's really an algebra problem. We just calculate the tax with the appropriate percentage and add it to the price tag, and then we get the total. But the given information is a little bit different here. The total purchase price, including 6.5% sales tax for a new refrigerator, was $734.85. That included the tax. What was the price of the refrigerator, excluding the sales tax, before we added that sales tax on? So the way not to do this, certainly, is to take 6.5% of $734.85. What we'd have to do to come up with the $734.85, if we didn't know it, is take 6.5% of whatever that price tag on the refrigerator was. So that's the unknown. Let's let X equal the price of the refrigerator, excluding tax, and let's just think through how we would calculate the sales tax if we knew the price of the refrigerator. If we knew the refrigerator was, oh goodness, $700. How would you calculate the sales tax if the rate was 6.5%? That's it. $700 times 0.065. That would be the sales tax. And then to come up with the total amount that the customer has to pay, you would take the $700 and then add the tax. So let's see if we can do this. So the refrigerator price plus the sales tax equals $734.85. We can calculate the sales tax by multiplying the refrigerator's price by 0.065. Almost left that term before I'd written the X. We take the refrigerator's price, which is X, and we multiply that by 0.065, and that gives us the sales tax. Add that to the refrigerator's price, and that's the total amount the customer has to pay. We need to combine like terms. What is X plus 0.065X? 1.065X. If you want to think of X as 1.000X, and then line up the decimals and add the 1.000 to the 0.065, then you get 1.065X, and that's equal to the $734.85. So I like to think of it like this. If there's a price tag on that refrigerator, we want to calculate, okay, did we bring enough money with us? What are we going to have to pay to get this thing out the door? We take that price tag and multiply by 1.065. And then that would give us the total amount we have to pay. If we somehow know the total amount we had to pay and we're trying to think, well, what was the price tag on that thing? We would do the opposite of multiplying by 1.065. We would divide by 1.065. So if we now divide both sides by 1.065, that should give it to us. X, and we'll round to the nearest cent if we have to. $690 even. All right. Easy enough to check that answer. Take the $690, multiply by 0.065. That'll be the sales tax, evidently $44.85. Add that to the $690, and that's the total price, total amount the customer has to pay, $734.85. So the price of the refrigerator, maybe the price on the refrigerator, was $690. Takes a little bit of thought. If you're in a position where you have to do problems like this every day, you probably don't take the time to set up the equation. You just take the sales tax rate, you add 1, and then divide by that 1.065, and that'll take care of it for you. Similar problem is the next one. No money involved, but I think the idea is about the same. The number of exchange students from a particular country, let's say to this country, was 11,008. 11,008 exchange students last year. However, this represented a 14% decrease from the previous year. It had been quite a few more the previous year, and it decreased by 14%, all the way down to 11,008 exchange students. How many exchange students visited from that country, during the previous year? What was the number before it was decreased by 14%? There we go, from the previous year. So there's an unknown quantity. We want to take that unknown quantity, we want to decrease it by 14%. And when we do, we'll get 11,008. So how about this? X minus, how are we going to decrease it by 14%? Subtract 14% of it, 0.14. And that'll give us 11,008. If we combine like terms, what is x minus 0.14x? 0.86x. So something to keep in mind here. If you want to decrease a quantity by 14%, what you're really doing is calculating 86% of that quantity. 86% of the original is the original decreased by 14%. So if we divide 11,008 by 0.86, this should give us the original number before it was decreased by 14%. So 0.86x, divide that by 0.86, divide 11,008 by 0.86. And I suppose if we don't come up with a whole number of exchange students here, the error will not be that it's a fractional number of exchange students, but simply that 14% was a rounded value. So how many exchange students were there the previous year? 12,800? Here we go. 12,800. So $12,800 exchange students from that country. During the previous year. If we take the 12,800 as a quick check here and multiply by 0.14, you see it's going to drop by 14%. What is 14% of 12,800? $1,792. If we take the 12,800 and reduce it by that 14% decline, Did I borrow one from that too? I don't think so. It's down to 11,008. Okay, checks out there. So you want to be careful in a problem like example 3 or example 4. There's a percentage given, and there's the value given. The temptation is just want to calculate 6.5% of that $700-something, or to calculate 14% of the $11,008. But just make sure, ask yourself, 14% of what? 14% of what we're given, or 14% of some unknown quantity that maybe is going to require me to set up a linear equation of some sort. Here we go. A couple of these, the dreaded distance rate time problems. In my view, a little bit more complex than some of the other problems in this section because there are more unknowns. A problem such as this, typically we go with the relationship among the quantities distance, rate, and time, what is the relationship among the quantities distance, rate, and time? Distance equals rate times time. D equals R times T, or RT equals D. If we needed to solve the equation for R, the T would go in the denominator. If we need to solve the equation for T, the R would go in the denominator. Equations where that's necessary are not going to fall in this neat little category of linear equations that we're dealing with in this section. Rational equations, we can deal with those at a later time. But this is the relationship that we'll look at for example 5 and example 6. Now what we see here, for each jogger, we've got two joggers, Mary and Terry. For each jogger, there's a distance, there's a rate, and there's a time. What we want to look for in a problem like this, for each one of those three quantities needs to be given the exact amount. Either we need to be told both Mary and Terry's distance, the exact distance that each of them jogged, or we need to be told both Mary and Terry's time, the exact amount of time that they spent jogging, or we need to be told both Mary and Terry's rate, the exact rate of speed at which each jogger was jogging. So let's look for that and then see if we can use that information to fill in a table. The other two quantities, whatever's left, there'll be relationships between those quantities, but we probably, well, this is just a really easy problem, probably won't be given the exact value of either one. So Mary jogs for 1.25 hours each morning. That's her time, 1.25 hours. And Terry jogs for 0.75 hours each morning. That's her time. So right there, we're told the exact amount of time that each jogger spends jogging, and that's the first thing we'll put in the table when we fill that out in a moment. Each morning, Mary is able to jog 2 miles farther than Terry. So we've got a relationship between their distances. Yeah. Even though going to say Mary's average rate of speed is 1 mile per hour less than Terry. So there's a relationship between their rates. There's a relationship between their distances that's given. One goes 2 miles farther than the other. There's a relationship between their rates that's given. One is 1 mile per hour, faster than the other. Find the distance that each jogger jogs each morning and the average rate of speed of each jogger. So 4 unknowns here, 2 distances, 2 rates. But what's known is the time. So let's go ahead and fill in the times. We've got the time is given in hours. So let's put hours up there. Mary's time is 1.25 hours. That's how long she spends jogging. Terry's time is 0.75 hours. Now there's a relationship between the rates and a relationship between the distances. And we could let our variable, the variable that's going to show up in our equation, be somebody's rate, or we could let it be somebody's distance. I'm going to recommend that we let it be somebody's rate. Because if we let it be somebody's distance, if we say let D equal Mary's distance, then to set up our equation, we're going to have an expression here. Rate equals, well, we could probably get by with this. Rate equals distance divided by time. It's just we'd have a 1.25 in the denominator. It wouldn't be pretty, but it would still be a linear equation, so I suppose it would be all right. I'm going to suggest that we let R be somebody's rate. Would you like it to be Mary's rate or Terry's rate? Terry's rate? Let's see what that would mean for us then. Did you say Terry's rate? Terry's rate, okay.
So Mary's would be R minus 1.
So Mary's average rate of speed is 1 mile per hour less than Terry's. So if we're talking miles per hour here, miles per hour, if Terry's rate is R, then Mary's rate 1 mile per hour less. There we go. So that's the relationship between their rates. Now, here's what I don't want to do. I don't want to put D's in this table as an indication of the relationship between their distances. I've got to use that relationship to set up an equation in a moment. But right now, I know that distance equals rate times time. So distance equals, well, 1.25 times R minus 1. Can go ahead and fill in that portion of the table, because if I multiply those two quantities together, that's going to be that distance. And for Terry's distance, that's going to be 0.75 times R. So we've got an expression for the distance in terms of R. We've got an expression for Terry's distance in terms of R. If we can use this relationship that's given between their distances to set up the equation, we should be good. So there's Mary's distance. And then there's Terry's distance. Are they the same? Do the joggers jog exactly the same distance each morning? Not the same. Not the same. It says Mary is able to jog 2 miles farther than Terry. So what quantity is greater, Mary's distance or Terry's distance? Mary's distance. If we knew Terry's distance, let me just throw a number out. Suppose Terry's going to jog 5 miles. Then how far, did I say Terry? Terry's going to jog 5 miles. How far would Mary jog in that case? 7. And how do we get 7? Plus 2. Plus 2. So if we have Terry's distance and we want to calculate Mary's distance, we would add 2 miles to that. Common mistake is to put a minus 2 there. Did it feel like minus 2 might seem more appropriate than a plus 2? Mary's able to jog 2 miles farther than Terry. Somehow if we can translate that to Mary's distance is equal to Terry's distance plus 2 more miles, then the equation I think makes sense. Mary's distance, that's going to be 1.25 times R minus 1. Terry's distance, 0.75 R. And then if we add 2 miles to that, I'm going to drop the miles with the understanding that the rate is going to be calculated in miles per hour. If we solve this for R, this should be Terry's rate. So far, so good. I think this is going to give us Terry's rate. I hope it does. 1.25 R minus 1.25 equals 0.75 R plus 2. We've got r terms on both sides. What would you like to do to get those r terms together on the same side? Subtract one of them from both sides. Maybe the 0.75r. That does a couple things. It keeps the coefficient of r positive. It keeps the r term on the left. So it's all good. Win-win. Subtract 0.75r from both sides. And let's just focus on that step for a moment. 1.25r minus 0.75r. I want to say is 0.50r. And if we'd rather not write the 0, it's fine. We can leave that off. I'll probably leave it off at the next step. Minus 1.25 equals 2. Isolate the r term by adding 1.25 to both sides. .50r equals 3.25. Calculate the value of r by dividing both sides. I kept that 0, didn't I? I really thought I was going to let it go, but I just didn't. Divide both sides by 0.5 or 0.50. And r is its rate. So miles per hour. How many miles per hour? 6.5 miles per hour. That is Terry's rate. So we're supposed to find the distance each jogger jogs. We're not there yet. And the average rate of speed of each jogger. Well, we've got Terry's average rate of speed. We just need Mary's average rate of speed. Mary's a little slower. 5.5 miles per hour. So Terry's average rate and Mary's average rate. We know how long each jogger jogged. So we should be able to calculate the distances that they jogged. So Terry's distance is going to be her rate times her time. 6.5 miles per hour times, it gave us the time, 0.75 hours. The hours divide out, and we get 4.875 miles. There we go. Now there are a couple of ways from here we ought to be able to get Mary's distance. And they ought to agree with each other. Ought to get the same answer both ways. And if we do, we feel like we've done the problem as well as we could have done it. Mary went 2 miles farther than Terry. So Mary would have gone 6.875 miles. But let's see if we can get the 6.875 miles by multiplying her rate by her time. So Mary's distance equals 5.5 miles per hour times 1.25 hours. Is it the 6.875 miles that we need? Here we go. How do you feel about this one? Some keys here. Settle on a variable. Although there's 4 unknowns, settle on a variable. Decide that you're going to look for R and let R be the variable you put in your table, and don't put a D in there. Or you actually could decide that you want to find somebody's distance. And you could put D's in the table if you want to, but then don't put any R's in the table. Use the relationship between the rates then to set up the equation, if that's the way you want to go with it. So that's probably, when I see this problem missed on a test, the most frequent way it's missed is there's some R's that show up in this column, there's some D's that show up in this column, and there's really no equation there. You want to use one of those relationships actually to set up the equation like we did with Mary's distance, Terry's distance, and the plus 2. Looking at the clock, and I'm wondering, do we have time for this one? Well, we have time for this one for sure, but there's also example 7, example 8. So I tell you what, for example 6, let's go with the setup, and then I'm just going to walk away from this problem to example 7 before we actually solve it. But let's see if we can get the setup here. A lot of deja vu that we'll run into here. Seems like maybe we've seen something like this before. Mary jogs for 0.5 hours longer than Terry jogs each morning. Mary jogs at an average rate of 5.5 miles per hour, and Terry jogs at an average rate of 6.5 miles per hour. Each morning, Mary jogs 2 miles farther than Terry jogs. Find the distance that each jogger jogs each morning and the time it takes each jogger to complete her jog. Look familiar? Okay, the unknowns. Well, let's look and see. Does it tell us both joggers' rate, both joggers' time, or both joggers' distance? It tells us the rate. So let's go ahead and put the rates in there. So Mary's rate in miles per hour, 5.5 miles per hour. Terry's rate in miles per hour, 6.5 miles per hour. Now there's a relationship that's given between the times. Mary jogs 0.5 hours longer than Terry jogs. So we could let T be somebody's time and fill in the second column. There's also a relationship given between the distances. Mary jogs 2 miles farther than Terry jogs. We could let D be somebody's distance and fill in the third column with expressions with D's in them. But we don't want to do both. So what would be your preference? We want to let T be somebody's time or let D be somebody's distance? T. Let T be somebody's time. So what's that relationship again? Mary jogs for 0.5 hours longer than Terry jogs. Want to let T be Terry's time? All right. Let T equal Terry's time, and then Mary's time, T plus Mary jogged longer, T plus 0.5. Don't put any D's in the third column. Instead, use the relationship distance equals rate times time and calculate based on the rate and the time. Calculate that distance. So 5.5 times the quantity T plus 0.5, and then 6.5 times T. Now, at this point, we use that same relationship between their distances that we had in the previous problem. Mary's distance, and then there's Terry's distance, and they're not equal. Mary jogs 2 miles farther than Terry jogs, so Mary's distance is greater by a couple of miles. So we can set up the equation. We have an expression for each jogger's distance in terms of T. So our equation is 5.5 times the quantity t plus 0.5, and that equals 6.5t plus 2. And if we solve this equation, we should get the same value we got for time, or maybe the values we were given for time. In the previous example, what were those values? 1.25 hours for Mary, 0.75 hours for Terry. So I would recommend solving this and see if that's what you get. If so, it'll be exactly the same values as we had in the previous problem. But rather than finishing this, I'm going to move on to example 7. Questions about this one before we walk away from it? No. Example 7. There is a problem in the homework involving cashews and peanuts, and a mixture of cashews and peanuts that's similar to this one. The way the problem is worded, it looks like it expects a two-variable approach. I think it says let x be the certain number of pounds of one of them, maybe the cashews, let y be the certain number of pounds of the peanuts. You could use a two-variable approach, you can use a one-variable approach, it doesn't matter. You just want to, when you input your answer, make sure and you input each one the correct number of pounds. Whether you use both an x and a y or just an x, as I want to do here, doesn't matter. A premium blend of coffee valued at $7 per pound is to be mixed with a standard blend valued at $3 per pound to obtain 80 pounds of coffee valued at $4.50 a pound. I mean, what we hope is that when we mix these two blends of coffee, it's actually worth something. It's not just so ridiculously bitter based on the incompatibility of the two blends that nobody would want to pay anything for it. We'd like to think that it's going to have value, and what would make sense would be that it's probably better than the standard blend because it's got some premium blend mixed in it. So it'd be more than the $3 a pound, but not as good as the premium blend because it's got some standard blend mixed in it. So something less than $7. So hopefully $4.50 a pound would make sense as a price somebody willing to pay for it. Now, if we want to do this in such a way that the sale of this coffee generates exactly the same revenue if we sell the blend as it would if we were to take the amounts that we use to put the blend together and sell them separately, then we can set up an equation and figure out exactly how much of each blend of coffee to use. So if we want to go with the one variable approach, want to let x equal let x equal the number of pounds of premium blend, standard blend. Anybody have a preference? Standard. All right. Number of pounds of the standard blend. If there's going to be a total of 80 pounds coffee that we're going to use, then how would we calculate the number of pounds of the premium blend that we're going to use? So 80 minus x. 80 minus x. What the two variable approach does is it keeps us from having to go through that thought process. We have basically x plus y equals 80. And if we wanted to express y in terms of x, we subtract x from both sides and we get y equals 80 minus x. So the two variable approach, all it really does is save us having to think, oh my goodness, if there's x pounds of standard blend and a total of 80, what's an expression for the number of pounds of the premium blend in terms of x? If you can come up with that 80 minus x, without having to write down a second variable, then you save yourself the two variable approach. value. We need to set up an equation. There's the value of that X pounds of standard blend of, yeah, I'll call it standard blend. And I'll put in parentheses $3 a pound. If we add that to the value of the 80 minus X pounds of premium blend, $7 a pound coffee, there's the X pounds here, there's the 80 minus X pounds there. We're going to mix it all together and get 80 pounds of this mixture, and the value of the 80 pound mixture should be the same. Well, the same as the sum of the two blends of coffee going into it. So if we've got X pounds of coffee and we're charging $3 a pound for it, what's the total value of that X pounds of standard blend coffee? There we go. Take $3 a pound, multiply by X pounds. That's how much it's worth. Folks are paying for it. If we have some coffee that's so good that folks are paying $7 a pound for it, and we have 80 minus X pounds of it, if we simply multiply the price by the weight of the coffee, that'll tell us the value of that premium blend coffee going into it. We're planning to charge $4.50 a pound for the mixture. If we charge $4.50 a pound, and there are 80 pounds of that mixture, the total value of that we can calculate directly by multiplying 450 times 8. What is $4.50 times 80 rather? Sorry. Multiplied by 80. $360. So this 80 pounds of coffee, if we're charging $4.50, it better be worth $360. So we've got ourselves an equation which I believe we can solve then. So it's going to be $3 times X plus, if I multiply $7 by 80, is that going to be $560?
Yes.
$560 minus $7 times X, and better make that a little bit cleaner there. That's equal to $360. Actually, the numbers might work out pretty nice here. Combined like terms on the left-hand side, we're going to have negative $4 times X. Isolate the X term by subtracting $560 from both sides. And get negative. Is that what we get? Negative $200 on the right-hand side? X then, once we divide both sides by negative $4, is going to be a number without a dollar sign. It just represents a number of pounds. How many pounds? 50 pounds. So X was the standard blend. So 50 pounds of the standard blend. How many pounds of the premium blend then?
75, sorry. 80 pounds.
Total of 80 pounds. So subtract the 50 pounds from the 80 pounds.
30.
So 30 pounds of the premium blend. What's the value of 50 pounds of the standard blend if it typically sells for $3 a pound? Yeah, $3 a pound times 50 pounds. That's going to be $150. You folks will pay $7 a pound for the premium blend. And we're going to put 30 pounds of that premium blend in there. That has a value of what? 210. So the total value of the coffee that we put in is going to be $360. And is that what we would get if we sell the 80 pounds for $4.50? $360? Okay. So the same revenue either way. Looks like 7 minutes and change. 7 minutes and change. I want to take a peek at this last example here. Notice the graph on the right. If we want to minimize the freezing point of a mixture of antifreeze, if it gets really, really cold, lower freezing point is a good thing. If you want it to be as low as possible, according to this graph, a 60% mixture, 60% antifreeze, and then 40% of the water is better than 100% antifreeze, and it's even a little better than 50% antifreeze. So 60%, you'll notice from the picture, 60% makes that freezing point just as low as it could possibly be. Here's the situation. To minimize the freezing point, a portion of a 50% mixture of ethylene glycol antifreeze is to be drained from a car's radiator and replaced with pure antifreeze. Well, that'd be one way to do it. Another way to do it would be just to empty the radiator, drain it all, mix up 40% water, 60% antifreeze concentration. You'd have to have 8 liters of the mixture, and then fill the radiator, and then it wouldn't require any algebra, right? That might be far simpler, slightly less environmentally friendly, I suppose, but it would be a far simpler solution than what's proposed. What we're going to do, we just want to strengthen it a little bit, from 50% to 60%. So right now, we're going to drain off a little of what's there, which is a 50% solution, and replace it with pure antifreeze. And if we replace a little bit, exchange 50% for 100%, that's going to strengthen it a little bit. And depending on how much we drain and then replace, it's going to strengthen it maybe to 51%, 55%, 60%, 70%. So we're going to see if we replace it with enough to make it a 60% solution. So here's the idea. We decide how much we're gonna drain off, and we drain X liters. So the radiator's sitting there with 8 minus X liters of 50% solution, and then we're going to add X liters of pure antifreeze, and when we do that, we want a solution that's 60% antifreeze. So maybe we can at least get the equation set up. The amount of pure antifreeze in the 50% mixture that's currently in the radiator after we drain off the X liters would be 50% of 8 minus X. 8 minus X, that's how much fluid is in there. X liters are gone. So it's 8 minus X left. 50%, that's how much of what's in there is pure antifreeze. We're going to add X liters of pure antifreeze, so 100% of X is what goes in. Then we'll have 8 liters of fluid in there, and we want that 8 liters of fluid to be 60% antifreeze. So we want 60% of that 8 to represent the amount of antifreeze that's actually in there once we're done. We might actually be able to solve this equation in 2 minutes. Let's see if we can. Half of 8 is 4 minus 0.50x plus x equals 4.8. I think it's 4.8.
Yeah.
Combine like terms. If I combine negative 0.5x with x, I'll get positive 0.5x. So 4 plus 0.5x equals 4.8. I managed to make myself drop the 0 in that case. Subtract 4 from both sides. And 0.5x equals 0.8. If we divide both sides by 0.5, what do we get? 1.6, and it's 1.6 liters. 1.6 liters. Have 1 minute and change. 1 minute and change. So what we've started with, in this case, is a radiator, and I know this is not radiator shaped, but I dare not draw something like that, where, what's 8 minus 1.6, anybody? 8 minus 1.6? 6.4, so 6.4 liters, and it's a 50% solution. So how much actual antifreeze is in there? What's 50% of 6.4?
3.2.
Yeah, 3.2 liters. Now we're going to add to that less than a minute. Less than a minute. Will time run out? Probably. We're going to add to that 1.6 liters of pure antifreeze. How much antifreeze is in 1.6 liters of pure antifreeze?
1.6.
And when we're done, what we want is a full radiator with 8 liters of 60% antifreeze. And what's 60% of 8? I'm out of time.
4.8.
4.8 liters. Thank you very much. Make sure you sign the class roll. There it is right here. Thank you very much. Can you reach that? Yeah, I got it. Okay.